All right. Hello, everybody, and welcome to what is the 260th episode of the Kohi Game Engine series. Hope everybody is doing well tonight. We are going to be picking up kind of where we left off last night, although much further down the road than we were last night, because I was able to get some stuff done off camera before stream. So I'll briefly touch on that, and then we'll get into what we're actually going to work on tonight, which there's hints there on the screen. But before we do that, I do want to just take a quick second and thank the supporters of the channel, starting with our elite partner, who is Javier Olazaran. That is the highest tier of subscription over on YouTube memberships and Patreon. I'd also like to thank our partners, who are the next tier of subscription there. They are Gobroli's Inc. and Matt Osgard. And I'd like to thank all the other supporters listed here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, and Twitch subscriptions. So thank you all very much for your support. It means a lot to me and helps me offset the costs of things like software licensing, hosting fees for the website, things like that. So it is greatly appreciated there. Speaking of greatly appreciated, I appreciate each and every one of you viewers, whether you're joining us on the Twitch side or the YouTube side. I do have those chats here on separate monitors. I keep an eye on those. And we do simulcast to both. So whether you're catching one of those live or you are on the VODs just catching up afterwards, thank you guys for being here. Without you, the viewer, this project would not exist. So thank you guys for being here. Enigma Dev, how's it going? Good to see you. And Cans over there, or Cons, I'm not sure how you pronounce that, but hello. 2 streams in 2 days, let's go. Yeah, so normally I do stream on Wednesday nights and Thursday nights. So that's kind of it's become the regular schedule, if it were. As it were, rather. All right. So last night, we were moving what I thought was going to be the final thing over in terms of asset management. And that was the scene. And I went ahead and completed that offline. That's done. And then what I also wanted to do for tonight was I wanted to remove the old resource system. Because that's kind of been like a big thing that we've been working up towards. And I did that. But it broke the audio system because I forgot that the audio system, most of which lives in a plugin, actually relied on that old resource system too. So I was going to put the management of our audio system off until the next release, but we can't very well start the development of a game without an audio system, right? So the audio system is truly the last thing that we're going to tackle. I also should mention that I did get a resource handler in place for height map terrains. So, yeah, that's more or less what we're working with tonight. So we still don't have terrains loading because we need blended materials, but we do at least have the loader for that, or the handler knocked out, and it does work. So this is really the last bit here, which is our audio system, which, to be honest, kind of needed some work anyways, because I slammed it together in a weekend, and this is one of those scenarios where it's a system that really needed attention anyways. So we're going to go through this and make it act as a lot of the other systems do, in terms of having a asset handler, a resource handler, an importer process, our own binary format, which we're going to define tonight. Yeah, that's kind of what's on the roster. I don't know that we'll get all the way through this. Essentially what I have to do is I have to take what's over here in this audio loader, and we're going to port it to the new way of doing things in our new resource system / asset system. So, I hope all that makes sense. Let me just answer this DM real quick. All right. So, the way that this worked before, and this is kind of a little bit talking about how the resource system, the old resource system worked before, is assets and assets and resources were kind of one and the same thing. So we had what was called this audio loader, which hooked into the old resource system, and we used two different libraries to load audio files. And this is one of the only places that we're actually using libraries outside of image formats, right? So we have the STB Vorbis library that we're using. It's a header-only library. And then we have the mini MP3 library that we're using as well. And these are really lightweight libraries, just because I didn't feel like writing a whole decoder for this. There wasn't really a whole lot of value in doing that, when we can just use these to load those formats. And then our audio loader actually kind of was also an audio manager, where it would actually handle the streaming of the audio assets as well, which isn't really correct. And so we are going to do a little bit of separating concerns tonight. We are going to stick with these two libraries, but we're going to change the way that we actually handle it. So up until now, it's basically just used those audio files as is, either an STB or either a OGG Vorbis file or an MP3 file. We're not going to do that anymore. What we're going to do is we're going to take the either Vorbis data or the MP3 data, and we are going to transform it into pulse code modulation, which is a standard audio format that OpenAL understands. PCM is the short for that, right? So we're going to transition all of that data into PCM, and then we're going to store that in our own proprietary format. Now, this does come with the drawback that it'll make the file size a little bit larger, but I'm not planning on having any huge audio files, at least for the first round of this. So what that means is, yes, we'll have a little bit of larger files. We will go ahead and work some sort of compression later on down the road. But for right now, that's what we're going to do. We're basically just going to take all these source formats and import them into a PCM format. And then the engine is just going to use that PCM format. We may do something a little bit fancier later, like building in decoders into the engine and decoding that stuff on the fly. But I'd really like to make this work this way first. So with all that, we also had a concept in here called audio files, and this contained an audio file type where we had sound effect or music stream. And I haven't really decided that I want to keep or get rid of that yet. I'm kind of leaning more towards getting rid of it. But the basic difference is that sound effects, essentially the entire audio clip is loaded into the buffer and played all at once. It's designed for quick things that go. Versus a music stream, which is very long, and we just pull that streaming data in as we actually need it. So I may wind up either renaming how this works, but we'll probably keep those independent concepts. Those are independent of the file formats. So we have a couple of different concepts here we have to keep in mind. So the audio file kept the type. It kept an audio resource, which was something that the old resource manager needed. It kept the format, so like 16-bit stereo, for example, the number of channels, the sample rate, and the total number of samples left when we are streaming the audio file, right? So most of these concepts we're going to keep. These two may or may not. This one definitely won't be kept. The audio file type may or may not be. And then we had this audio file internal, which was basically the compression and or decoder data that was needed for that. And then we also had internal plugin data, which is like the OpenAL specific stuff. So the audiophile plugin data more than likely will be kept. We'll have to see if we can't maybe handle that a little bit more gracefully and use handles instead. Kind of like what we do on our renderer, instead of having sort of an opaque pointer here. And then we're going to do some things like we're going to get rid of these function pointers and just, kind of clean things up a little bit and make it work a little bit closer to the rest of our systems. We also had this weird audio emitter structure here, which we kind of just hacked in place just to get spatial audio working. We're going to do away with that as well. And that's going to be something that is going to be configurable in the scene. So we are going to be adding audio emitters with configuration and all that stuff into the scene, so that we can actually place those audio emitters in the scene. And then this structure as it stands will probably wind up going away and being replaced by something different. Thank you for the follow, by the way. Appreciate that. Dingus Dev, how's it going? Thank you for the lurk. I appreciate that. Okay, so we also have this audio backend interface, which may wind up getting some updates, but I think a lot of this can mostly stay as it is. I think the only thing that we're really going to have to change is, let's see. Actually, do we deal with audio files in here at all? Yes, we do. So anywhere we're using these audio files, we're going to wind up using a audio resource instead. So we do have quite a bit of work here, but I assure you by the time we're done, this is going to be a lot easier to use than it is now. Because like I said, I just banged it out in the weekend and it was kind of a hacky mess, right? So where I'm starting with this is I'm starting by writing the asset importer. And so we have a new audio importer. And this only contains one function for now. We may also have an exporter for this to be able to take that PCM data and maybe export to these various formats. But for now, I don't think we really need to do that. We really just care about importing. And so what this does is it basically gets a size of data, and it gets a block of data. So what we are going to do is we're going to load in a source file, and that's just going to come across as a big whopping block of data. And then we're going to decode it from there. So I've made some modifications to the asset manifest. And so we actually have, we've changed this up a little bit, right? So we have a few different files in here. And I think I've made most of the modifications that I need to make. Although this name is kind of terrible. Maybe we'll do that. Okay, so we have this Woodland Fantasy, which is sort of an open license song that I downloaded. We have one of those for an MP3 format. We also have a mono version of that. And so the reason for that is, typically speaking with the audio system, if something is in stereo, it just plays without any sort of spatial interpolation, right? It just plays over the speakers as sort of what I call a 2D sound. And so, you can't like attach a position to it. You're not going to hear it panning from side to side and things like that. So if you wanted that, you would want to use the mono version of that. And then we have a fire loop, which is basically just a fire sound effect that loops over and over again. We have that in MP3 and OGG format, right? We also have a second fire loop sound. We have a test audio sound, which is an OGG, and then we have an unlock sound, right? So these are just kind of random sounds that I just found that are decent little tests, right? The fire loops are a little bit longer. The test audio, I don't remember what this one is, but it's relatively short, and then the unlock is like a super short sound, right? And so essentially, with the way that this is going to work is when we say, hey, I want the resource Woodland Fantasy, right? we are going to look in the path first, right? Which is going to look for a KAF file. We haven't defined this yet. We're going to define that. And so the KAF file is Kohi audio file. And so it's going to look for that first. That's going to be that binary file that we talked about, that new format that we're going to create that contains that PCM data. If it doesn't find that, it's going to say, okay, let's see if there's a source path. If there is a source path, let's grab that source path and throw it at the importer, right? We'll just read in the whole file and toss it over the importer. That's where this guy comes into play. So he's going to take all of that data, decode it, depending on, and I think we're going to switch this based on, file extension here. So, we have MP3 in this case, so we'll go through the MP3 decoder. And in this case down here, we have the OGG file format or file extension. And so we'll go through the OGG Vorbis decoder, right? And those are the only two formats we're going to support for right now. Anything else, we're going to throw an error and say, hey, we don't support that yet, you dingus. And that's going to be that. So that is basically the way that this is going to work. And then we're going to be able to take that audio resource and use it in conjunction with the audio system. And that will resolve handles and do everything it needs to do under the hood in order to play sounds and rewind, start, stop, pause, all those things. So naturally, the first part of this, I think, should be the importer, because that's going to be the first step, right? We're no longer going to use the source formats for this stuff. We are going to import it first, and then we are going to read in our binary format. That way our engine does not have to worry about all this decoding stuff, right? At least for now. Okay. So I was kind of putting together a little bit of a conceptual what this, let me just go back here, what I'm thinking this importer might look like, right? And I just kind of started, what I did was I essentially took the image importer and I'm using that as a template, which is why there's still some image stuff down here. Essentially I'm going to do the MP3 first, and then I'll come back and do the OGG Vorbis portion second. So the goal for this is basically we want to decode the entire audio file. And MP3 is encoded in such a way where you can't just like look at the length of the file and say, hey, this is how much data I need. It actually varies based on, the differences in the sound and all that stuff, right? So essentially what that means is that we are going to have to decode the entire file. And then only then will we actually know what the final PCM size is going to be. Now, it's been a while since I've looked at this, so I'm going to have to refamiliarize myself with some of it, right? So this right here, this is initialize the decoder, right? And I'm just assuming MP3 for now. We'll switch on it in a minute. So we have an offset, and that offset is going to be an offset into, that's going to be an offset into the buffer, right? So let's see. We have the MP3 data is what we're going to call it. That's just a cold cast to a U8 of the data that's passed in here, just so that we can iterate that nice and cleanly. We have the decoded PCM. So this is going to wind up being, this is going to be the entire audio, I should say the entire, audio files, decoded PCM data, right? So we start off with this being 0, right? And note that we're using 16-bit integers here because we're dealing with 16-bit audio. We could extend this to be 24-bit audio, but I don't think that's really necessary. So we have the decoded PCM here. We're going to basically be reallocating this as we need it, right? Because we have to sort of keep the data as we decode it, but we don't know the entire set of data until we're done decoding it, right? So unfortunately, this is going to involve several reallocations, but it does only happen on an import process. So I'm okay with it. We're not going to have to do that once it's actually decoded. So this is going to be the final decoded size of the PCM data. And then I actually don't think we need the previous size. So what we do here is we get a bytes decoded every time we call this MP3 decoder decode frame. So frame is just a length of data within that audio buffer, right? So we pass it the decoder, we pass it the MP3 data plus the offset, right? So this is that the source data that's coming through. We pass it that offset, right? And then we take the data size, which is this entire source size, and we pass it the amount remaining. So we say there's data size minus offset, right? So as this offset increases, this number will get bigger, this number will get smaller. And then we output it into decoded PCM. And then we also output something called frame info, which contains a little bit of size data that we need. So I don't think I 100% have this correct here. So what we actually need is like a, I guess we could call it we could do it in here actually. I guess we could just call it PCM, right? So we need a I16, and it's going to be an array of that. It's going to be PCM, PCM. And I believe there is a frame size declared in here. Max samples per frame, this one, right? So this is going to basically tell us how many samples per frame we can possibly have, and this is the max number, right? So like I said, it can vary, and so that's essentially what we have there. So I'm just going to initialize that to 0, and then when we go to actually decode, instead of actually decoding or going to decoded PCM, we just want to go to PCM, right? And so what this is going to do is it's basically going to say we want to decode a single frame of audio at this offset. Here's the remaining data size. We want to put it into this buffer, which is allocated on the stack. And then we want to output some frame info that tells us how big that actually was, etc. And then that returns how many bytes we actually decoded. So we can look at that then and say, oh, wait a minute, bytes? No. That's sample count, my bad, right? This should be an I16, right? So if the sample count is less than 0, then we say that there's been some sort of error, right? In other words, if it's negative. And I just know that just from having, glanced at the code. All right, so offset is going to be, it's actually not going to be bytes decoded. We're going to want to do the frame info, frame bytes, right? And so we're basically going to move that forward by the number of bytes that we got back in that particular frame. I think we can actually move this guy in here. He doesn't need to be outside the loop. Offset does. MP3 data does. Decoded PCM and decoded PCM size. Those can probably stay there, I'm thinking. Yeah. So we'll add to the decoded PCM size, right? Just add that same amount to the total size. And then what we're going to do is we're going to say, okay, our decoded PCM, we are going to reallocate. And note that we start off with 0 here, right? So it starts off as null, reallocate, acts as alloc when we first when we call it the first time. So we're going to say we need to reallocate this. Oh, that's why I had the previous decoded size. This should probably be... We should do... I guess it should probably be... Oh wait, does this return an I16 or that's an int? That should be an I32. That's what was throwing me. Okay, so we have an I32, and we're going to say previous decoded sample count. So we basically need to know the previous size of the buffer, right? Actually, no, we don't even need that. That's stupid. What am I doing? We could just do this afterwards. Yeah, so we could just do decoded PCM size. That should probably be renamed to sample count to make that a little bit more clear, because it's not really a size. Well, I guess it kind of is, though, because we are doing... Yeah, ignore that. We are using frame bytes. I'm just trying to... I'm trying to separate in my head here between samples and size. Okay. So does that account for... Does the frame bytes account for the size of this, or do we have to add it? I'm thinking since they put frame bytes in there, we probably don't have to multiply that by the size of. Right, so we can do plus frame info, frame bytes. So when we reallocate this, right, we move the offset. Then we say decoded PCM, we reallocate that. Here's the old size. The new size will be that plus frame info, frame bytes, right? Then we update the decoded PCM size by adding frame bytes to it. We don't need that. And I guess we should probably just do this, right? If the realloc fails, that's a bad time anyway. Okay, so we do that. And then we need to append the data to the buffer. So that's just going to be a straight up memory copy, right? So the source, or sorry, the destination of that is going to be decoded PCM, which is going to be this guy right here. And that's going to be plus PCM size. Minus bytes. I feel like if we do that and it's an I16, that's going to be a problem. Let's change this to an I8, right? Because otherwise, pointer arithmetic there is going to be bad. So decoded PCM plus decoded PCM size minus frame info frame bytes, right? So is that right? Is that right? Right, because we have to undo this. So we don't have to do that if we just shift this down here. Right? So we don't have to do this if we just hold off on adding that until after we actually append the data. And then, oh, this shouldn't be bit rate. This should be, the amount of data we want is frame bytes. And then, wait a minute. Do I have, this should be source, not the size. The size should be last. what we want is PCM here. Okay. So we copy PCM into decoded PCM plus decoded PCM size, which hasn't been incremented yet, so it would be the correct offset. Yes, okay. And then we copy this number of bytes. Yes, okay, all right. So, once we've done all that, why do we have a warning here? Oh, this should be an I8. Okay. So once we've done all of that, that should be all we need. And then we should literally be able to just say, I guess we would just probably convert decoded PCM to an I16, right? And that would be what we'd actually store in the file. So I guess at this point, we probably need to talk about how we're actually going to store this data, right? Because we need the PCM data, right? We need to know the size, the PCM data, but we also need to know some additional information about it, right? So we have this ks.audio type that we made that has all of these various things in it. The PCM data size and PCM data are here. The total samples left, actually, that doesn't need to be here. That is in the resource. The only things that we really care about is the format, the channels, and the sample rate. Yeah. Okay. So we essentially need to fill out this structure with all the stuff that we need. So we can say typed asset PCM data equals, we'll cold cast this to I16, and we'll say decoded PCM, and then typed asset PCM data size. That's a U64, so we're going to have to cast that. And we want the decoded PCM size. Oh, that is a U64 up there. Okay, yeah, I guess we don't need this then. Okay. All right, so we fill those out. And then, let's see, we're also going to have to get... We're also going to have to get the other pieces of data that we need. So we need the channels, the format, and the sample rate. Is that included in the, let's see, in the file info? Thank you for the follow, appreciate that. Let's see. Diamond, good to see you. How's it going? I'm doing well. Thank you for asking. Addicted to Factorio. Coding is gone for a hike for a couple months. Yeah, I refuse to pick that game up because I'm afraid of that. 100%. Singy, good to see you over there on the YouTube side. How are you doing? Standard Pointer, good to see you as well. Hello. All right. Now these things, this mostly I got from our old loader. And so we do have that file info structure. STB Vorbis get info. That's Vorbis. We don't want that. We want, and I guess actually this, should we get this full sample count actually? We should probably save that off too. Yeah, I'm going to save that off too. So we're going to say a U32. You know what? Let's do a U64. I don't think we'll need something that big, but total sample count equals 0. So we can do total sample count plus equals sample count. And we'll need, because we have the sample rate here. You know what? I am going to stick with the U32. Total sample count. Can't imagine that we would need larger than that. Okay. All right, so we keep a running total of that, so we can actually fill that out too. Total sample count equals total sample count. Now, we do have this file info, but I don't think we're actually using that anywhere. So where did we get that? Over here. Let's see. So MP3 decoder load. This, okay, so this requires a file path, which I don't want to do. I don't want this opening the file. I want to feed it a stream of data that I've already opened. I guess what I could do, let's see, file info, internal data MP3 info. Yeah, that gets written right here. Do we have anything in here? Frame info. Well, frame info has it, I guess. I guess that's probably what I have to do, is just get it from the frame info. Okay. So, do I set it every time? That feels kind of stupid. I guess I could just punt that upwards, right? And then I'll just have it at the end here. So I can do typed assets, and then I guess I would do channels, and that's going to be frame info channels. Oops, typed assets sample rate equals frame info bit rate kilobytes per second. Is that do I need to convert that? We weren't having to do that over here. Average bitrate kilobytes per second. We're just using hertz here. Do we not have... Oh, we do have hertz. Okay. And then typed assets format. What were we using for format over here? Do we actually use format at all, actually? Apparently not. Okay, well, I guess we don't need it. So what I'm going to do... I guess we've never used that. Oh, you know what? I think that's an OpenAL thing, actually. I think that was part of what OpenAL needed to know. So our asset doesn't need to know that. Okay. Okay, so here is all the stuff that audio data. There's all the stuff that we need to know, right? So now we need to write a serializer that outputs all of this stuff to a binary file. And then we can actually just call something like we did here for images for this. So I'm actually going to use this as my template. And we'll have a serialize and a deserialize in this case. We're going to need both because the serialize is what is going to give us the binary blob to write to disk. And then the deserialize is going to read that binary blob from disk. Because I think yeah, so we basically just need to follow this almost exactly, right? So we have the asset type, the header, the file header, right, which contains most of the data, and then the actual data block itself. This serializer, so the importer is going to live in the plugin utils, right? That's where our importer is for audio. So that makes sense. That's only available on like a debug build or the editor or something like that. But the serializers for this need to exist here in core. And that's so that we can read and write them as we need from anywhere, including the runtime. So I'm going to, like I said, I'm going to copy the binary image serializer and we're going to rename it to binary audio serializer. Oops. Copy, paste. Cool. All right, so this guy will just open here real fast. Attempts to serialize the asset into a binary blob. Okay, so this is pretty self-explanatory except for, I don't think we're going to have to change comments at all, actually. We just need to replace image with sound. And then this is going to wind up being the same thing. And we'll basically just work from the top to the bottom. So binary sound header. This is going to have some of the stuff that we had here. So we want like channels, sample rate, total sample count, and PCM data size. Everything but PCM data, essentially. So we want to keep the binary asset header base, but all the rest of this is going to be there. So that we don't have to like figure this stuff out when we read this in. So essentially the way that this is going to work is we're going to jam this into the file, and then we're going to jam essentially this into the file, and that's going to be that. Okay, so we do not have a k-asset type sound, and that is because I believe I had separated them into audio and music. I'm going to call it audio, not sound. I'm going to stick with audio. I'm going to delete music. And we're going to specify streaming versus audio effect within the sound itself, in terms of how it's actually used as a resource. So, cannot serialize a non-sound asset using the sound serializer. Okay. Let's do... I should have used audio, the word audio instead. Let's actually... Let's go back to the header file and do the same thing. In fact, I called the file audio and then I just wrote sound there for some reason. I don't know why I did that. Okay. So the first thing has to be done is we have to verify, and this we're going to do deserialization first. Or should we do... Nah, let's do serialize first. Right, we'll do the writing first, then we can just reverse that. So the header is going to have our asset magic number first thing, right? And that's our 0x cafe babe, right? So if we don't see that as the first bit of the file, then we know it's not a Kohi asset. Then we'll put in the type, and then the data block size. The data block size is going to be typed asset PCM data size, right? Always write the most current version. We only have version 1 for this. I'm not going to worry about specifying anything else for now. Okay, so we are going to do header PCM data size equals typed asset PCM data size. Header, I guess we'll do sample rate, typed asset sample rate. Channels equals typed asset channels. And then total sample count equals typed asset total sample count. And then what was the last thing? Actually, I think it's just those, and we already filled out the base, so that's good. Okay, so we need this plus PCM data size. All right, so the out size is going to be the size of the header and the PCM data size. We allocate a block of memory. We copy in the header. Then we copy the block, right, which is basically going to be offset by the binary audio header. And then this is going to be, instead of pixels, obviously it's going to be PCM data. And then PCM data size. And that's going to complete the serialization, right? Not too much to that. And so here we just basically have to redo this in the opposite direction, right? So all of this should have been pretty much taken care of by find and replace. Looks like it has been. The only thing that we'll have to do... Yeah, the only thing that we'll have to do is just a memory copy of the actual audio data block. Okay. And obviously the stuff from the header. So let's do the base stuff first. Right? So we'll do this. Type is most important. Out audio base. What is out audio? That should be out asset. We need to typecast that. We don't have to do that, however, until, well, I guess here. Yeah, that's, wait. Does this not have, oh, that's why. We're missing the base. Okay, so that fixes that. Channels. Total sample count. Doesn't really matter the order that I do these at the moment. Sample rate. And then what was the last one? PCM data size. All right, don't need that. And then we can copy the actual audio block rather. So we're going to say PCM data, and we're going to k-allocate that. And so that just needs to be PCM data size. And then we're going to do PCM data and PCM header block data size. That's fine too. They should be the same value. Okay, so there's our deserializer. So now we can go back to our importer. Right here. And we can actually do new and include on that. We don't really need that one. Let's see. Okay, so get the VFS state. Here's where we serialize that. Serialize block size. Okay. Binary audio serialization failed. We'll just do that. And then VFS asset write. So we have the out asset. We're going to write that to disk. I think that true is binary. Yes, it is. Serialized block size, and then the serialized block of data. And then we're going to do binary audio asset. And then we can free the serialized block. Yes, because we don't need it anymore. It's been written to disk at that point. Okay, so that's the importer. That only covers MP3s though. So we need to handle Vorbis next. And pretty much this section of code here is going to be the same no matter which format we use. It's this that's going to vary. So let's take, let's see, do we need offset? Offset is really that, so we can move this down. We really just need these. And arguably, we could actually write directly to the typed asset every single time and just eliminate those altogether. Decoded PCM. Yeah, I think that's what I'm going to do. Instead of having this, we could just write it directly to the typed asset, right? We don't have to have it separate like this. And then do this at the bottom, right? Because it'll already be here. So let's get rid of that. We'll say typed asset total sample count. We'll add that. We'll do typed asset PCM data, but we're going to That's an I16. And we want typed asset PCM data. Typed asset PCM data size, which is also going to be the same for that. And then typed asset PCM data is going to be there. This is going to be there as well. And then typed asset PCM data size, same thing here. So that way we're just writing to that every single time. And I suppose we should probably zero these out up here, though. There. So now we can get rid of these, because those are just written in place. Okay. And then that'll just be written going forward. Okay, cool. So, let me see. Spiro raiding with a party of 12. Thank you so much for the raid, my dude. Appreciate it. How are you doing tonight? Welcome, raiders. We are revamping our audio engine. I forgot that I had to do that as part of the refactor. But we're already a decent way into it. I don't think it's going to take all that long. With any luck, we'll have it working tonight. I don't know. But we'll see where we land. You're going to lurk in moderation mode? Nice. Yeah, so for those of you who aren't following Spiro, he is another developer here on Twitch who's making a game. He's writing his game engine in C, and then he is compiling that to WASM, and he's using the HTML DOM as his renderer, which is super interesting. So definitely go check out his channel for sure. And yeah, as far as what we're working on here, we're working on a game engine from scratch written in C. We are revamping our audio system right now as the final part of a fairly large refactor. All the stuff that we were working on last night is already done. This is literally the last system that's in place that has to be refactored. And that was just because the original audio system, I banged it out in over a weekend. And you know, it needed some cleanup anyways. So we're addressing that stuff. We're making it use our new resource and asset systems. And yeah, that's pretty much where we're at on that. All right. Let's see. Hi, is the refactor fixing already over? Yeah, the refactor fixing is done. So I finished that up off stream. There was only maybe about half an hour worth of work that needed to be done after we wrapped up last night. So all of the bug fixing, at least for now, I think is done for that. We're obviously going to do some testing and whatnot to make sure before we actually cut new release. But yeah, that's mostly done. And what I actually did is I ripped out the old resource system, and that was when I figured out it's like, uh-oh, I broke the audio system by doing that. So we are in the process now of fixing the audio system to do things the way the rest of the engine does. Love Holy, how's it going, man? Dingus Merge, yes, exactly. Ghost Magic, how's it going? Hello. Quick rundown on audio. Yes, okay, so our audio system is a little bit different than a lot of our other systems in that it has a couple of layers. I guess you could say it's somewhat similar to how our renderer works. So there's a front end and a back end to it. The audio system front end is what the rest of the engine understands, right? It's just the generic handling of audio files on the front end. You know, playing, pausing, stopping, rewinding, saying, hey, load this file, whatever. The audio backend is can technically be multiple things, right? We have chosen to use OpenAL um, to actually process our sounds. So we've written a backend in OpenAL. You could also use Fmod or something like that. We might have other things down the road. But the backend is a plugin, just like the Vulkan renderer is a plugin for the renderer, right? So it works very much the same way. So the issue with the way that the audio system was written initially, and like I said, I did this very fast over a weekend, is similar to how we were doing resources in a couple of other places on the old system. We had something called an audio file, which already kind of doesn't make sense. But we had an audio file, and that was both the asset and the resource, but also the player, which was weird, right? Because it handled streaming from the asset file as well. And that was also decoding on the fly, like decoding MP3 on the fly or decoding Ogg-Vorbis on the fly. And so what we're doing with the new version of the audio system, and most of the work is going to be around the actual resources / assets, is we're going to set up an importer similar to what we've done for images, where we have source files. So I'll pull up the asset manifest. So we have source files. Let me make sure this is not behind my fat head here. Right, so we've got entries in our asset manifest that look like this, right? So they have a name and a path and a source path. So the path is this KAF file. That is going to be the Kohi audio file. And that's going to be just a binary file that we actually literally just wrote the serializer for. So that's going to be basically hold the audio in PCM format for now. We might handle some compression in the future, but for right now, we're just going to do PCM, right? It's easy to work with. OpenAL understands it. I don't have to do a lot of translation there. So the path has been changed to that, and then the source path is either an MP3 or an Ogg-Vorbis file. And so what we do is we have an importer that runs. So the resource handler for audio files or audio assets, right, is going to be looking at, hey, try and load this binary thing first. If this exists, use it. If it doesn't exist, then do we have a source path? If we do, go ahead and import it. That importer gets called, and it says, okay, depending on the file type, MP3 or Ogg, let's go ahead and decode the whole thing into PCM, and then we're going to write it with some header information and whatnot to a Kohi audio file. And then that will be what gets used to load in the future. And so that's sort of the process that works there, or that's being developed now. So so far we have the asset handler set up, we have the importer set up, and we have the binary audio serializer set up. And so the importer, I'm just basically filling out all the logic to get things decoded. And then once that's done, it goes ahead and fires it off to the asset system to say, hey, go ahead and write this thing out, right? And so we've done the work for the MP3 format. And so this is, I should also mention, this is one of the few places I am actually using a library for this. And so under our Kohi plugin utils, this is a utility plugin, is where our importers exist. So our font importer exists here, our system font importer, our OBJ importer exists here, and then our image importer exists here, and now also our audio importer exists here. And so the reason that we put this here is because this plugin is only included, or will only be included, in debug builds. And so if this importer is not registered with the plugin system, which it won't be for a debug build, then it won't actually be able to import, right? So even though there's a source path here, it'll say, hey, well, we have this, we don't have this. Sorry about your luck. But that shouldn't be happening on a release build anyway. So we locate our importers and eventually our exporters here. as a way to handle that. So yeah, that's kind of where we're at. And where I'd left off is MP3 is basically the first decoder that we've used, and we are using mini MP3 for that. And then we're going to use STB Vorbis for Og Vorbis. We already actually had a lot of this stuff written in this old audio loader. This audio loader was essentially what was it was behaving as the asset, the resource, as well as the streamer slash decoder. So yeah, long-winded way of saying it's in progress, but yeah, I hope that helps. Samples per frame, I guess you're not using a lib. Yeah, we're only using a lib to decode the stuff, right? So we are decoding it into PCM, and then PCM we can actually feed directly to OpenAL. Rudimbo, first time chatter, welcome. How's it going? Surprised you support MP3. Why are you surprised? I feel like that's a format that needs to be supported, right? Wave is on the list as well. I just don't have that written yet. From what I understand, that's a pretty easy format to work with. So we might actually write the loader. MP3 isn't very popular in game dev. Fair enough. But there's no reason it couldn't be. Couldn't be used, right? I just figured it might be nice to have support for, more than one format out the gate. Og is the way. Yeah, Og is what I default to, but I wanted more than one format. MP3 can have issues with seamless looping. Yes, I have seen a little bit of that, if the file isn't set up right. But we are converting to PCM, so I haven't, once I'm dealing with that PCM data, I haven't really noticed huge issues with that. Wave is a must, yeah. So we're going to be doing Wave 2. I have to look at the file spec for that. I don't think it's all that complicated. I think it's like the audio equivalent of a bitmap file. So I'm hoping that will be pretty quick. But for right now, it's just MP3 and Og. And then Wave is actually on the to-do list. So, all right. Let's see. A couple questions over here on the YouTube side. This must be the very last steps before you can start making your game. It is, actually. Yep. What would be the first element you'd make for your game? There must be something in the top of your list. Yeah, so the first thing is probably going to be start hammering out the pathing, right? Because it's going to be like an endless runner, right? So we need the ability to path and switch lanes and go around curves and go up hills and stuff like that. So that's probably going to be one of the first things we're going to knock out, which is going to be interesting because we don't have a path system. So we're going to have to make one of those. Probably just going to be in game code, and then we can move it out of game code after the game is done. Genuine question. I'm still on number 70, and the scene elements are all in the engine, and the testbed is almost empty. How do you have it now? Is the scene still in the engine core, or has it moved out? The scene is in the engine core. However, the render graph, which gets implemented after that, is heavily configured in the testbed, which I do want to actually fix. The game code is really should be very, very light when it comes to those things. So, the problem with MP3 is the MP3 codec can have some empty frames before or after the sounds. Always cleaner to use Wave. But now we can import our music library in the game. Yeah, exactly. And like I said, it gets converted to PCM. So I don't really think I haven't really run into issues with that. Any chance of doing a devlog vid on your game dev environment someday? Editor setup, switching OSs, etc. Not sure if it was in a past vid or not. I do have something that should. Let me grab a link real quick. Actually, I think it was. It's not the entire setup. Let me see if my bot is actually awake tonight. Doesn't seem like it. All right, hold on. Oh, there it goes. So there's a link for you regarding my NeoVim setup, and it's mostly up to date. So that goes into a lot of detail and like how I have things set up. But it doesn't go into detail in like my debugger and stuff like that. But that stuff is all configured and included with the project. So at some point, I probably ought to do a video on it. You're right about that. Let's see. How difficult would it be to write C# bindings to replace Unity? I think it wouldn't be difficult. It would just be annoying, I think. But I have really no reason to write C# bindings. There's no reason we can't write our game code in C and just make it hot relatable, frankly. Floated the idea of doing some Odin bindings, need to learn how to do that. Oh wait, are you talking for scripting or are you talking for bindings for the engine? Neither one of those would be really very difficult though. Have you gotten to optimizations already? Not really yet, no. Let me see. I'm studying for my electromagnetism exam, and your live helps me concentrate, even if I don't understand anything. Well, I appreciate that, and welcome, by the way. Dingus-oriented study. Yeah, we do dingus-oriented programming here. All right. So I need a way to determine. Thank you for the follow, by the way. Appreciate that. I need a way to determine whether we're dealing with, what the source file is essentially. So when we import, we can have parameters. So we might want to set up something that tells us, what the base file format is. So let's actually go to let's see. We have import options here, the source path, right? Is that going to be something that... So this is in the... I guess we could pass it in from the resource handler if we happen to know. I almost feel like I'd rather have like an enumeration that I could just check instead of having to parse a string, right? And maybe I'd leave it up to whatever is actually calling the importer to be aware of what the heck it's trying to import. Because by the time it gets to this level, we shouldn't really have to be figuring that kind of thing out. So I'm going to do a type def enumeration, and we're going to say supported audio types, I guess. I don't really like that term, but supported audio. No, I don't like that. What we really want, I guess, is source audio types. That makes more sense, right? So we can say source audio type MP3, source audio type, should I just type Vorbis or Ogg Vorbis? Let's just do Vorbis. And I guess we'll do source audio type wave. Even though it's not technically supported right now, it's something we want to add. So I guess in here, we can just do the source audio types type. Actually, I think I'm going to do away with the S. Source audio type. Yeah. All right. So we have this as our import options, right? And we'll use that to determine what we're actually importing, right? So we're going to have options. And this is just going to be what is called params, a cold cast of params. And what we're going to say also is if we don't have params, we're going to abort. Requires a k-asset audio import options to be passed in params. Right? Okay, so now we can tell from our options what the type is. So we can say if options type source audio type MP3, then we do this bit all the way to here. Okay. Yeah, okay. So the next one is going to be, and I suppose I could have done a switch here, but I feel like in this case it's going to be a little bit cleaner to do it this way. Options type equals source source audio type Vorbis. And then we're also going to do one for wave. But we're going to bleat here and say k-fatal wave not yet supported. And we'll do a fix me support wave. There. Okay, so a k-fatal will basically throw a it'll throw an assertion and then, or it'll fail an assertion rather, and then we'll get that message, right? So now we need to handle Vorbis. And that was in here as well. And I think actually, I believe Vorbis, we actually had things set up to jam the whole thing into, yeah. Okay. So essentially, I think it's going to be a little bit easier, maybe, to do this with the Vorbis library. So let's see. I guess I could do a little bit of trace right here, right? Let's do, just so we get something in the logs, we're going to say importing, oops, that's the wrong one. Importing MP3 asset, and we're going to do kname string get out asset base. Oops, base. Oh, right. That is the base. Okay. Okay, so we're going to do that, and then we're going to do one here. And I think we said this was just Ogvorbis asset. All right, so we're going to take I'm going to take all of this bit and put it here. And then we want to, the way this worked before is if it was a music stream, we'd only load part of it. Otherwise, if it was a sound effect, we'd load the whole thing. So I'm now going to load the whole thing. Let's see. I think that is, so we did that, and then this, and then just need to fix it. So, okay, stb vorbis open file name. We don't want to use that. We want open memory. All right, so our data is literally going to just be data, and then what was it? Data size. And then the error, I believe we just passed in that, I believe. I think that's what we were using before. Yeah, here we go. Aug error. Yeah, okay. So we want the address of aug error, and then the alloc buffer. Does this? First off, what is this? What does this actually return? We don't need any of this. stb vorbis. Decode an entire file and output the data interleaved into a malloc buffer stored in output. Okay, the comment is wrong because there's nothing there called output, but that's fine. The return value is the number of samples decoded, or -1 if the file could not be opened or was not a... Okay. When you're done with it, just free the pointer returned in output. I feel like that comment is just like in the wrong... I feel like that's talking more about this one. Oh, he put the comment afterwards. Dang it, Sean. All right. Create a decoder from an aug vorbis stream in memory. Note this must be the entire stream. Oh, can I not? Decode memory, I think, is what I need to do. I might need to use this one, actually. Decode file name. What was I doing over here? I think I was doing... I did open file name here, which gave me this guy. Actually, it seems like this is the one I'm going to want to use. Because it gives me, wait a minute, not that one, memory, this one. memory block length, and then it outputs channels, sample rate, and output. This is probably what I want to do, and I'm guessing this is the number of samples. Yeah, this comment was actually... This comment's actually for this. That's confusing. I'm glad I opened the file. Okay, so we actually want to do... I'm just going to copy this one, actually. What we actually want to do is this. I32 samples. Is that... this is going to be data size. Channels is going to be, can I do typed asset channels. That might be the wrong type. Typed asset shoot, what was there before? Sample rate. And then output is going to be the address of typed asset PCM data, I think. I'm not 100% sure that's correct. Why is typed asset complaining? Oh, because it's here. And it shouldn't be. It should be up here. Okay. That's a U32. Let me guess, it's expecting an int. I think it's safe enough. We could probably just do this. Okay. Parameter type of int. Oh, that should be data length. Why is that? Or data size, rather. Okay. So that returns the number of samples. So that's going to wind up being typed asset total sample count. What are we missing? We have channels, sample rate, total sample count. PCM data size is the only thing that we don't have. Free the pointer, return and output. Let's see. Return value is the number of samples decoded, or -1 of the 5. Okay. So how do I find out the size of what this is? Let's do decode memory. Oh, that's going to be in the C file, isn't it? Okay, so output equals data. So, yep, we're doing a realloc. Wonderful. Okay. So this is total times size of the first element in data. So, okay. So times of short. Okay. Is total actually... We just increase this by 2 every single time. Data equals data 2. Okay, so we're just redoing that every single time. Data length. So really, this is what we want. We want total. It's not returned anywhere. Boo. And I'm not seeing anywhere where I could extract it from any of this stuff. Do we have... I thought I had something in here where I was... I could have swore that I had something in here that was... let's see, buffer length. Length and samples. Can I just do samples times that? We return data length. So data length is going to be... Yeah, because this gives me samples. This is what I was using here. This gives me the number of samples read. So data length gets... Okay, so that is indeed samples. Okay, so it looks like here the buffer length was samples times that, which seems to be... This is technically just doubling every single time, but it doesn't look like we're actually using that. Data equals data 2. So that's just moving that over. Output equals data. So we're setting this continuously. Okay. So I guess I really can just take this and multiply it by the size. That's what I'm getting. Let's see. An engine with many bindings would be nice. Yeah, so I probably will do other language bindings for this once it's far more stable, right? Let's see. Yeah, I would agree, LaFoley. It's definitely going to be a waste of time because there's big changes coming down the road too. So yeah, I definitely would not do it. At least until after we cut a 1.0, which is quite a whiles away. I don't even think 1.0 is going to be around by the time I finish the first game, to be honest. Is it possible you're not receiving data length? Look at that early return statement in the loop. I might be wrong. That might be a failure value, my bad. Are you talking about this guy? So essentially what this... Oh, return -1. Oh, this right here. Yeah, so this basically is saying if the memory that we send it is poop to return -1. So I do need to check for that to make sure that that doesn't fail, obviously. Because that would be bad. All right. I think I know what I need to do, though. So instead of doing this, that's technically not really safe, right? Total samples is going to be that. If total samples is less than 0, then there's been some sort of error. Failed to import Vorbis file. And then return false. Right? We do need to check that. If that's successful, however, then we can do typed asset total sample count equals total samples. Right? We could just do that. And then, let's see, do we even need the error thing anymore? I don't know if we actually do. This doesn't actually do that, it seems. Okay, so actually, let's see, sample rate, total samples left. Yeah, we don't need most of this stuff. Okay, so actually what we need to do is, oh, you know what? One more thing. I don't want to write directly into this. I want to copy to it after the fact. Because it specifically said to do free on that, and that buffer can be different size than what our buffer winds up being or actually using, right? So let me do a, what is that supposed to be? Pointer to a short array. All right, so an I16. And I guess I'll probably wind up doing the same thing that I did. I guess I can do, let me think. I guess we'll say decoded PCM data. Oops, that needs to be an array. Equals 0, right? And then decoded PCM data, right? So we'll keep continuously writing to this guy. If not decoded PCM data, or we get a negative return value, then that's a failure. Okay, so at that point, then we'll have U64 buffer size equals typed asset total sample count times size of I16. And then we can do typed asset PCM data size. Actually, we should just use that here. Right, and then just do PCM data equals we'll just do kallocate. Typed asset PCM data size, and for the memory tag we will use asset. Okay, so we have that, we have total sample counts, sample rate, channels. Is that it? I think it might be. Yep, okay. All right, so all this crap can go. Don't need it anymore. Oh, and might help to actually copy the data. So typed asset PCM data. Decoded PCM data, and then typed asset PCM data size. There. We'll take that, and then I do need to free. Which the only crappy part about this is I can't use my free because it goes to my custom allocator, and this allocates memory outside of that, which I'm not a huge fan of. I wish I could control that, but I think for an import, I think it's fine. I might actually have to call free on this because I don't think... I know in some of his libraries he has like a special free thing that reaches out to... Yeah, that's it. Okay. I guess I'm just going to actually have to call free for once. And this is going to be decoded PCM data. Okay. So the next thing we need to do, actually, I think this is actually, that might actually make it done. All right, so at this point, in theory, we've either imported an MP3 or we've imported a ogg-vorbis file. And then gone ahead and taken the resulting PCM data and serialized that to a binary audio file. Written it to disk. And then got rid of the serialized block. And our out asset already has everything it needs, so we don't actually have to reread that off of disk, and then we can return success. So I think that actually makes this done. So the only other thing that we need to do, well, we need to register the importer. Let's see, that's going to be... Where was that? I think it was in the plugin main for this guy. Yes, okay. So we need to... I'm going to copy the image example again. And we're going to say audio, 1 per file extension. So types. So we're going to have MP3, OGG. These are file extensions, FYI, and WAV. Even though it's technically not supported yet, we'll go ahead and put it in there anyway. All right. So we basically have a separate importer for each one of those things, which actually, now that I'm thinking about it, we don't even need the input parameters. We could just specify that when we make the importer. I think. So it takes the source type, which is here. Oh, I forgot that I could actually access that from within the importer. Oh, that makes things a lot easier then. Okay, what I'm actually going to do then is we don't even need this stuff here at the bottom. We don't need that. We don't need this. We can actually simplify this even further, and we don't need import params. Audio. All right, so we can get rid of all of this bananery. And we can literally just do source type, right? So this is going to be MP3. And obviously we can't do an equal like that. We have to do string equal. We'll do a case insensitive version of that. Right, and then we can just grab this. Because we have to specify this stuff anyways, right? So we can just paste this right here. And this is going to be og. Yoink. This is going to be wave. And we should probably have an else here too. Unsupported file format, you dingus. And I guess we can do source type. Yeah. Okay. So at least we get some sort of logging to that effect. While I'm here, let me also, I'm going to put this in here because I'll forget to do it later. Okay. So now all we need to do is just set up the resource handler. And then we can get rid of all of this loader stuff out of here because we don't need it anymore. And we can get all of that out of the audio backend and then just focus on the OpenAL portion of it. Okay, let's see. Is there an optimization reason why you put the game elements in the engine instead of plugin for the engine to load? One and the same engine can load several games. Sounds multifunctional. Let me see if I understand the question. By game elements, what do you mean by game elements, actually? Is there an optimization reason as to why you put the game elements in the engine instead of a plugin? The game is now part of the engine. That changes later on. Yeah, we had something called game before. Now it's like application. Yeah, so the game should not be part of the engine, right? But like as we were standing stuff up, it was kind of all together. So yeah, ultimately the game is separate, right? That's how we get our hot reloading for our game library and stuff like that. How do you handle the spurvy hot reload with glsl lang lib? Yeah, so we use the I use the shader C library that comes with the Vulkan SDK for that, which incidentally is something that is part of the Vulkan backend now. That probably should be like a extension plugin that's only actually included in debug builds, because we don't want that to go out with a release. So at some point I'm going to have to move that, but that's not a huge deal. Did you think to moving into Slang? Not yet. But I do want to investigate. I do want to investigate getting reflection to work in shaders, so that I don't have to have a whole bunch of metadata and configuration to set them up. But I'm also trying to consider, like, I need to do that not only for Vulkan, but also Direct 3D, and I'll need to do it for Metal. So I need to make sure that all three of those have really good support for that. And I'll have to figure out a way to make it work across the board. Okay, so next thing we need to do, and this is probably, we're approaching the end of the stream for tonight, but we can go ahead and at least start looking into getting the resource handler set up. So let's go to, it's going to be under runtime. And again, I'm going to use the, well, in this case, it's going to be the texture handler, which interacts with the resource asset handler, right? Or the texture resource handler interacts with the image asset handler. So I'm going to take a copy of this, and we're going to say resource handler audio, and I'm going to take a copy of this, do the same thing, right? And I'm just going to move this over here. I don't want to close it because I do have to kill a whole bunch of stuff in there. So we're going to do texture and replace that with audio. Globally. All right, and we also want to do the same thing in the C file. All right, and then we basically just have to go through here one at a time and fix these things, right? So we have K resource audio. Isn't that? Oh, right. We haven't created that type yet. So we do need to go to. We need to go here real quick because I need to grab this. Our resource is going to be somewhat similar, but contains some extra stuff. So K resource types all the way down here at the bottom. Kohi audio resource. Okay, whoops. Okay. So this is going to be a K resource audio. All right. And then this is going to be K resource base. So number of channels, sample rate, total sample count, PCM data size, and PCM data are all going to be held within the resource. But we also had a couple of other things. Let's see. In this audio file structure, this is sort of our old way of doing it, that I think we might need. So I think we needed format, right? And total samples left for when we're streaming music, right? Let's see. We also are going to need. So we have this internal data, which now we're not going to need anymore. And then we also have plugin data, right, which was kind of a pointer to. It's essentially what holds the OpenAL data, right? But we don't want to do it that way because none of our other systems work that way, and we've transitioned away from doing it this way. So what we're going to do instead is we're going to use our handle system, and we're going to say khandle, and we'll do backend resource, right? And so this one is a handle to the audio backend resource array, right? Or I guess it's not really array. It is a handle into an array, but we don't need to know that at this point. Okay, so the way that the audio is going to differ from the asset. The audio is going to take a copy of a lot of the data from the asset, right? So all of this stuff here, it's going to take from that. This stuff is going to be used by the audio system as well as the, well, probably just the audio system. And then this is going to be used to manage the audio backend stuff, right? So we'll probably have a handle lookup both in the audio front end and the audio back end that match up, similar to what we did in the Vulkan renderer, so that we can use the same handle for both the front end and the back end, and get the resources that we need at both levels, right? Because there's going to be things within the audio system that we need to know that maybe shouldn't be exposed to the resource. And I'm actually tempted. I think total samples left probably shouldn't be here. That should probably be tracked internally by the audio system. So I'm going to put a fix me here. Should be tracked internally by the audio system. And actually, this isn't, let's call this internal resource, right? Because it technically isn't just the back end, it's front end and back end. Spur V cross is very neat for shader reflection, and that's what I've been looking into, actually. Yeah, the Spur V cross. I have a different branch set up where I was kind of experimenting with that, but it's old, so I'm probably gonna have to rewrite it. But yeah, Spur V cross is definitely going to be the way to go for that. Let's see. How do you think why indie and single developers using C and C++ for game development? I think what you're trying to ask is, why are some indie developers using C over C++? It's a simpler language, for one thing. Compiles faster. And anybody that's used... well, okay, I guess I can't say anybody that's used C++ because a lot of people love it. I think modern C++ is a dumpster fire, frankly. But a lot of people who do low-level systems programming tend to prefer C over C++ for that, among other reasons. C++ is just a very bloated, complex language that doesn't really give a whole lot of value over C, except for a few things, right? At least in my opinion. All right. I guess let's go back. Let's see how far we can get in this in a couple minutes, right? Let's see. Audio resource, handler info. I might not actually need this. So there was a thing where we could potentially, in the image loader, where we could load more than one image at a time, but we're not going to do that for audio. Typed resource, typed request. Oh, we don't have, I don't know that we need a typed request, but I guess we should probably create one. Even if we don't need it, right? Because we can always add stuff to it if we need it later. It's probably not enough, yeah. So we want audio, K-resource audio. Right. Okay. Now, we don't have flags. We don't need to do any sort of validation. This is all image-specific stuff. This is image or listener instance stuff, so we may or may not need those. I'm not 100% sure that we're actually going to need this stuff for the actual image request or the audio request, right? We don't have import params. Let's see, load all assets might only be one. So in this case, it is only going to be one, and we have some other things down here that we don't need to handle as well. So this whole case can go away. If we don't have assets, we should probably error out, but we don't need to do any of this stuff either. So get rid of that. Okay. I guess let's do, we don't even have to loop through this thing, actually, because we're only ever going to have one. So if info assets base length is not equal to 1, then we're going to bleat about it. Okay, resource handler audio requires exactly one asset. Request failed. Right. So at this point, we can actually just return false. Right. The other thing that we can do is get rid of these and just say info assets data sub-0, right? And we want the address of that. So we'll get a pointer to that. And then this needs to be, obviously, audio. Asset name, package name, auto release true. Yeah, that's probably good. On result, we'll look at that in a minute. We don't want it to be synchronous. I'm not going to support hot reloading for audio. That just seems like a good way to have a disaster. Don't need that. We don't need params. Again, we don't need params. Okay, so we fire off an asset request. Single asset, right? Okay. If we're not going to do this. Wait a minute. Oh, that was more texture specific stuff. Okay. So we don't want to do that. So if the asset type is wrong, we want to say okay, resource handler audio asset must be of audio type. Okay, so there's that. All right, we're going to come back to the release because the on result is actually what we really want to handle. So, and again, this is way more complicated than it needs to be. I just want to make sure that the import stuff here is caught, right? So if we have a success, I think this whole thing is for success, right? So yeah, it is. So do we actually need... I don't know if we need this listener at all, actually. Yeah, because this had to actually handle multiple assets being loaded at once, which is not what we need. Okay, how do I want to do this? So I think what we need to do here is actually select all of this, because I don't think that there's anything in here except maybe that. And that. Okay. Els Dragoon raided me with a party of 40 viewers. Dang it, you beat me to it. I was just getting ready to end my stream. What's happening, my dude? Or my dudes? Thank you so much for the raid. I really appreciate that. If you guys aren't following Els Dragoon, go follow them. They're a duo, actually. They are tag teaming original Nintendo development and assembly. So very, very cool stuff over there on the stream. I was actually going to send you guys to them because I saw they were still on, but yeah, they left early just to get me. That's hilarious. So welcome, Raiders. We were just wrapping up for the night, but we're redoing our audio asset handling for our custom game engine that's written in C. And this is actually the last bit of a fairly large refactor that I've been working on now for a couple months. It's the last bit that we need in order to start making our first game with the engine. So as soon as this is done, we're going to start actually making a game using this. And I suspect we're going to have to circle back to the engine code quite often. But in our defense, we went for 4 hours and you're only at 2. Yeah, that's... C. Yeah, the whole thing is written in C. Let me give you guys just a quick and dirty intro here. So, and I'll drop a link as well. There we go. All right, so what we're working on is called the Kohi game engine. It's basically a game engine made from scratch using C. Its initial rendering backend is Vulkan. I say initial rendering backend because we do have plans to support Direct 3D and Metal as well. And basically, the whole thing is an educational exercise. So it's kind of the resource I wish I had to follow along with when I was learning how to do this stuff. So it started off as a tutorial series, but we quickly outgrew that format. Eventually, we landed here on this format here, the live stream format. We do simulcast to YouTube and Twitch. The engine itself is free and open source. It's Apache 2.0 license, so if you wanted to use it for personal or commercial use, it does not matter. All I ask is that you say that you used it. I do have a couple of, albeit aged screenshots here. We have a PBR pipeline. It looks a little bit better than this now. We've got cascading shadow maps. We have the ability to render bitmap and system text or true type text. We have our own UI system that we wrote from scratch. That's still very much in progress, but it's there. And here's another screenshot as well. We have the ability to select objects in the world and manipulate them with a gizmo that we also wrote from scratch. So we wrote all these different systems from the ground up. And so, yeah, that's more or less what the project's about. I did put a link there in chat, so if you're interested in that, you can check out the main website here. We have a couple of other links as well. We have a Discord server that's got over 1,000 people on it. And then, obviously, another link to the GitHub, YouTube, Twitch, Patreon, if you're interested in that. And then, of course, the stream down here in the bottom. Thank you guys for the follows, by the way. I appreciate that. So yeah, pretty exciting progress. I actually had just ripped out the old resource system out of the engine. So we were replacing our old resource system with a brand new, robust, shiny one that separates assets and resources and will allow us to load assets multi-threaded, things like that. We'll be able to jobify the whole thing. And so I actually had just ripped out, I thought I was done, and I just ripped out the old resource system, and then I would go, my audio system relied on that. So I wasn't going to do audio. I was going to put that off, but we're doing it now because we're going to need it for the game anyway. So um, this project checks all the Beef Vipers boxes. That's hilarious. Thank you guys for the follows, by the way. So yeah, that's where we're at. I am streaming at the moment from Linux, so that was another thing I somehow skipped over that completely. This engine is cross-platform, so it runs on Windows, Linux, and Mac OS right now. We have other platforms scheduled for the future, but yeah, that's basically where we're at, right? Okay, so I know you guys just rated me, but I do have to get up in the morning for work, and this is usually when I end my stream. And I was actually going to raid in the other direction, so I'm going to build a Linux box for my next PC. Actually, never used it before. I love it. Ever since I switched to it, I haven't really looked back. I only boot up Windows if I have to run a specific game that won't run under this, or if I have to, do Windows work for support of this engine. But otherwise, I use Arch, by the way. So, yeah, you guys knew I was leaving soon. Okay, well, yeah, I really appreciate it. If you guys are interested in this, though, I would encourage you to follow. I could definitely use the follows. My whole goal with this project, actually, is not only to release a game, but also to hopefully inspire other people to get into game engine development and give us some competition out there so that we don't have just, the big three, right? That's kind of the goal, right? So, real hackers use LFS. I love it. All right. So I'm going to find somebody to raid. Let's see. Who do I want to, let me see. Is there anybody that is in the same category right now that is doing something somewhat related? Sometimes it's easy to find, sometimes it's not. Bear with me just a moment. Let's see. Not a whole lot in terms of C or C++ game dev tonight, it looks like. So we might have to go a different route. You know what? I know where we're going to go. He's raided me a bunch of times. I don't usually get to return the favor. So we're going to go over to CM Griffing's channel and see what he's up to. And with that, yeah, thank you guys for joining me again tonight. And again, thank you for the raids. I really appreciate that. Yeah, we will catch you guys on the next stream. All right. See you guys.